The volume of a sphere comes down to 4/3 pi r cubed. This formula was founded by Archimedes, and it was based off Cavaliere's principle, which eventually led to integral calculus. He also found out that a sphere circumscribed in its cylinder is 2/3 the volume of that cylinder. So we can prove that here. So here we know that the volume of a sphere is 4/3 pi r cubed. And we also should know that the volume of a cylinder is equal to pi r squared times its height. Now, as you can see here, since this sphere is circumscribed in the cylinder, we know that this right here is r, and this right here is also r. So the height is 2r. So we can substitute that for the cylinder. Pi r squared times 2r, which goes down to 2 pi r cubed. So now that you know that, we're trying to see if the volume of the cylinder is really, the volume of the sphere is 2/3 of the cylinder. And so what he's saying is basically 4/3 pi r cubed is supposed to be 2/3 times the volume of a cylinder. And when you do the multiplication, you will see that this is indeed true, which is pretty cool that Archimedes found this out. So if you don't know the formula for a volume of a sphere, you can always use the volume of a cylinder and multiply by 2/3. The formula for the volume of a sphere can be used to find the volume of different balls. For example, a shot put has an area of 64 pi centimeters squared. Find its volume. So the formula for the area is 4 pi r cubed. So we can apply that here in order to find your radius. So 64 is equal to 4 pi r cubed squared. So we can cancel out pi immediately and divide by 4, which means r squared is equal to 16, which means your radius comes down to 4. So now you can put this into this equation. 4/3 pi 4 cubed, which happens to be 4/3 pi times 64. So again, we're going to have to multiply 64 by 4 since it doesn't divide by 3. So you end up with 256 pi over 3 centimeters cubed as your volume for the shot put.